Hi everybody, so today we're going to talk about Ebola, and if you recall, back in about 2014 we actually had a big scare of Ebola in the United States, which was basically overdone. For the most part, Ebola is not something to be really scared of. If you get it, it is, but for the most part, it's pretty hard to transmit. And in fact, since 2014, only about 5,000 people worldwide has actually died of Ebola. So let's take a look at Ebola. And the first thing is, let's look at where the name came from. Ebola is actually a river in Zaire, in Africa, okay? So there's actually 6 strains of Ebola. And the one that we're most familiar with is the Zaire Ebola virus. Okay, and normally these are named after where the outbreaks occurred, okay? So we have 6 strains. The Zaire Ebola virus is the one that's we're most concerned about. The Ebola virus is actually a filovirus, and what we mean by that is this. Especially now as I'm filming this, COVID is the big virus right now during the pandemic. But here's the thing is, if you look on TV and you see the COVID virus, you're used to seeing something that looks almost like this. It's a pretty crude drawing. Okay, that's the coronavirus. In fact, the reason they call that the coronavirus is because they say under a microscope it looks like a crown, right? A filovirus, these are going to be string-like viruses. So their shape is like a string. Okay, so that's the type of virus that we're going to have with Ebola. So let's look a little bit more at this. And how do we get Ebola? Well, first off, Ebola is found in fruit bats. So it's found in fruit bats, and then from there it's going to go to humans. Now, humans are considered what we call an end reservoir. Usually we don't pass it on to other animals. However, we can spread it from human to human. Okay? Ebola can also be found in primates, such as chimpanzees. And in fact, they had an outbreak in Africa in 1996. It was only about 10 people who got it. But what happened is they found a dead chimpanzee and they ate it. They cut it up and ate it, and the people who ate it ended up getting Ebola. It was infected. You can also get in other types, in monkeys, gorillas, so primates basically, okay? So like we said, it can be transferred from human to human. So how do we transfer it from human to human? Well, first of all, in order to be transferred, you must have symptoms. In other words, there is no asymptomatic transfer of this. Right now, like I said, we're in the middle of a pandemic with COVID, and COVID can be transferred when people don't have symptoms. In this case, people have symptoms. So when you have symptoms, what happens? You don't go outside, you're not around people, you may be in the hospital, right? So that's already got something that's going to make this harder to catch because you don't go around sick people. The second thing is it is transferred by bodily fluids. Okay? So let me give you an example. You can transfer this by saliva, so kissing, spitting, things such as that. You can transfer it through the blood, right? If somehow blood transfusions, which they usually will look at the blood and they won't give people contaminated blood. But if someone gets a cut and then you get in a cut, it can be transferred by semen. And in fact, men can actually carry the Ebola virus in their semen for up to 2.5 years after being infected. Lots of times, we'll go into this in a little bit. You can, with Ebola, people will vomit. So you can get it from vomit, you can get it from diarrhea. Okay? Ebola will cause diarrhea. And what happens in this case with diarrhea, when we had the outbreak in 2014, there was actually somebody in Dallas, and 2 nurses actually got Ebola, and they think they got it from because he had diarrhea, and he was basically excreting about 2.5 gallons of diarrhea a day, and that's how they think the nurses got it. Let me see. So I got saliva, I got blood, I got semen, I got vomit, and I have diarrhea. So there's an example of some body fluids. So let's take a look now at the symptoms. So here's our symptoms of Ebola. Someone gets it, it's going to take about 3 to 7 days before they start to see symptoms. But the first thing they're going to have is flu-like symptoms. Okay, so they're going to start feeling, they're going to have a fever, they'll probably have a headache, they'll probably have muscle aches, malaise, in other words, fatigue, right? Eventually what can happen is they can actually get bleeding coming out of orifices, okay? So because this is a hemorrhagic fevers mean you have a high fever and you have bleeding. So it'll be bleeding out of orifices. For example, and this is kind of one that always shocks people, you can actually get bleeding coming out of your eyes. Okay? You can actually have bleeding coming out of your nose, right? People may vomit. They actually may vomit blood, and that's called hemochrhagesis. H-E-M-E-T, hemochrhagesis. Okay, so that's basically bloody vomit, and with this, there's also like a coffee grounds appearance. Okay, it looks like the people have been eating coffee. Okay, the other thing is you get bloody diarrhea. And this is hemorrhagia, bloody diarrhea. Okay, so that's another thing. Oh, and hemorrhagia. So that's going to be bloody diarrhea. So there's some of the symptoms you have. Oh, and then of course you can have death. Okay, to treat this, what you can do is you can actually use. These people have a tendency to lose a lot of water and electrolytes. And so what will happen in those cases is if you can rehydrate them and replace the electrolytes, the survival rate gets better. Estimates on death is about 50%. Some books say 50%. I've seen 50% to 90%. But I've also seen other things that just say it's about a 60% death rate. So take your choice. It's somewhere in there. So let's talk now about the pathogenesis of this. So basically, the way that your immune system works is like this. This is going to be my filovirus. My Ebola virus. All right, that's my Ebola virus. So normally when a virus is going to enter into the skin, you have a type of white blood cell called a dendritic cell. Okay, and like I said, this is a white blood cell. Normally what this will do is when a virus comes, it'll bring the virus in. It's called phagocytosis. It'll pull this virus in. Now, normally what will happen is once a virus is inside of this, it actually, a piece of the cell, as it pulls it in, a piece of the cell membrane here will actually surround this. So I'm going to draw my cell membrane like this. Okay? And this is called the vesicle. So it's inside a vesicle. Now, normally what's going to happen is we are going to have another type of vesicle in here called a lysosome. And lysosome will actually hold enzymes that will be responsible for destroying things like viruses and bacteria. So it will actually bond with this, and then it's almost like it's releasing an acid. Okay, this is probably hard to see, but it releases these enzymes that will break this down. Then what normally the dendritic cell will do is it will also make, its DNA will also make, this is its nucleus, its DNA will also make kind of like a receptor. We call this MCH2, right? This is MHC2. And what it will do is we'll take an antigen or proteins from here, and it will actually stick those out here on this MHC2. Now, normally what's going to happen is it will bring this over to the lymph nodes, and your B and T cells will actually then see this, and they'll start a chain reaction in which they will go and they will actually make antibodies to this so you can fight it off. That's normally what happens. Well, in this case, what's going to happen is this is going to basically be released from this, and it's going to use your cell's own machinery. This is called a ribosome. So it's going to use a ribosome, right? And here's my DNA. It's going to release messenger RNA. Messenger RNA is like a recipe that tells you what proteins to make. And then what's going to happen is the messenger RNA is going to go through the ribosomes, and just to make a long story short, it will start to make more of the Ebola virus. And it just keeps multiplying and multiplying and multiplying and multiplying. Okay, so now what's happened is my dendritic cell, instead of being able to kill this off, will now just become a factory to make more of the Ebola virus. The other thing that it is going to do is it will actually start to make some proteins. Okay, it's going to start to make something called glycoproteins. Now, when cells become infected and they can't kill this and present it on an MHC2 basically receptor, every cell that has a nucleus also has something called an MHC1 receptor. Okay? And the MHC1 receptor normally has a protein on it that says, I belong here. It's a we call it a self-antigen. Okay, and it basically tells the body that this belongs in here. Don't attack me, I belong here. So now, when this is usually taken over, what the dendritic cell will do if it can't kill it, is it will, and other cells do this too, it will actually take that piece of protein that we saw and put it on here. Well, normally what's going to happen now is you will have something called a T cell, a cytotoxic T cell, and it will see this and realize it needs to kill this whole thing to stop it from making more of the virus. Okay, so this would see that and say, hey, you've been taken over, we need to kill you. That's called apoptosis. Okay, apoptosis is programmed cell death. Okay, so we're going to have programmed cell death with apoptosis. So now, here's what's going to happen. Is now in this case, this is not going to happen because when the Ebola is taken over, I have these glycoproteins, right? I'm just going to call them GP for glycoproteins. What they will do is they will actually go out to the cytotoxic T cell, and they will tell the cytotoxic T cell, you need to kill yourself. You need to undergo cell death. You need to undergo apoptosis. Okay? And now my cytotoxic T cells start killing themselves. Okay? You also have something that's called killer T cells, or natural killer T cells. Okay? And they basically do the same thing as the cytotoxic T cells. They're just activated a little bit differently. Well, these proteins are also going to tell this to kill itself. Now, eventually what's going to happen is I'm going to get so many of the Ebola virus in here that it's going to dissolve this cell membrane. And when it does, all of these are released now. And they're going to go out to other dendritic cells and cause the same problem. So the next step in the response is to basically, okay, so really quick, because I'm going to erase this. So all these are released now. They're going to go to other dendritic cells and start the same process. Now, another cell, white blood cell, that's usually in part of your immune response, is something called macrophages. Okay? And macrophages basically come from monocytes. So monocytes will turn into macrophages. And here's my macrophage, here's my monocyte, here's another macrophage. And here's what's going to happen, is we have the bloodstream, right? This is a blood vessel. And of course, inside our blood vessels, we have blood. So now, what's going to happen is normally macrophages work like the dendritic cells. They're going to attack, bring this there, present it, go over to the lymph nodes. But what they will start doing is we will actually start having the Ebola virus, and those glycoproteins will actually start taking these over and infect these. And what they will do now is they will cause my blood cells to leak, right? So now I'm starting to get fluid that should be in the bloodstream to start coming out, right? This is a lot of times that's a normal response, but in this case it's overdoing it. So the next thing that's going to happen is as these continue to come out, the macrophage will realize we're losing this battle, and they're going to call something called a neutrophils. Hey, neutrophils! Neutrophils are usually the first line of attack against bacteria. They usually don't work that much against viruses, but they're desperate here, right? They got to do something because they're losing this battle, so they're going to call the neutrophils. And here come my neutrophils. Well, neutrophils aren't used to fighting viruses, so now what my neutrophils are going to do is my neutrophils, let me go like this, there's my neutrophils, okay? And what the neutrophils will do now is they will cause these blood vessels to open up even more. And now you start to get the bleeding. Now I'm starting to get blood coming out. Okay, so here comes my red blood cells now. And that's now why we start to get the bleeding out of every orifice. Because my blood is now leaving the bloodstream and going into the body, and it's got to come out somewhere. It comes out the eyes, the nose, the mouth, all of that, okay? So far I've killed off my dendritic cells. They're just becoming factories to make more of my Ebola virus. My macrophages have had their functions changed because now they're just causing leakage in the blood vessels. My neutrophils, which usually shouldn't even be involved in this fight, have just made things worse. The next thing, and also my killer T cells and my natural killer T cells are also ineffective too. So all that is going on now, right? So now, what the Ebola virus is going to do now is, not only is it doing all that, it is going to go to something called your liver. So here's your liver. And now the Ebola virus is going to go in and start destroying the liver. As it starts to destroy the liver, I'm going to get more internal bleeding, which that was internal bleeding you just saw where the blood was coming out of the blood vessels, right? That was internal bleeding. Now I get more internal bleeding here. Eventually the liver may die. If the liver dies, you die. And now it's going to start spreading to other organs too, right? Such as the kidneys and the lungs and things such as that. So now it's going to start spreading to other organs in the body, and they're going to start dying. So you can see this is pretty bad. So as a last-ditch effort, the body's going to do something that calls a cytokine storm. And when it does this, it basically fires anything it has left in the immune attack, and it goes and starts to destroy this. The bad thing is, as you have the cytokine storm, what's going to happen is you'll also start to destroy your own body, right? So I always say it's kind of like if you have a fly in your house and you use a shotgun to kill the fly. Okay, you may get the fly, but you're going to cause damage. Same thing with this. In fact, in COVID, this is usually what kills people, is a cytokine storm. So in a cytokine storm, it's a last-ditch effort. It's an overwhelming immune response. Okay, and it damages your own body. Okay, and the bad thing about this is the more healthy your immune system is, the harsher the cytokine storm can be. So it's actually working against you in this case. But your body's kind of like you have nothing left to lose. We're dying, so we might as well do something. Okay, so that is Ebola. And again, it's nothing to be really worried about. It was a big scare in 2014. It's hard to get. When people get it, they're sick, so they don't go around people. And that's it for Ebola. Thank you so much for watching.